See, the last session which we have ended, where we covered how to compare the averages of two different data sets. Like if I have to make some conclusion relating to before or after, or a sample average with a constant. So, average comparisons. That is one attribute to a data. Average mean is one of the attributes of the data, right? The central tendency, the dispersion, skewness, and kurtosis. So the means testing was more to do with the central tendency aspect, right? And one more thing to highlight there was, see, now that we are moving into making inferences about a particular population, sample out of a population, one inference could be more about the averages. But at the same time, I also need to see how their dispersion is lying. Is there dispersion? See, probably averages of two numbers, let's say males, females. The averages of the males and females spending could be $100 only. So probably I may say there is no difference with respect to the spending patterns of both males and females. But that 100 as an average, for males, let's say there is no fluctuation. Mostly either it is a 98, 99, 100, 101, 102. That's how the different people were spending. Whereas when it comes to females, there were people who were spending 30, there were people who were spending 170, but still the average was 100 only. Then I cannot say the averages of these two are more or less the same, because they are average wise, because of this sample which I have taken, looks like more or less they are same. But what is happening is, because of a heavy fluctuation that is occurring, we don't know in future their spending could be much higher compared to the males. So the predictability becomes a problem. So that's where there is an understanding on, apart from testing of your means, apart from comparing the means, we should also look at comparing the variances or standard deviation. Standard deviation is a better measure, right? The name is called analysis of variance, but our intention is primarily to compare either the standard deviation or the variance between the two sets of data. Again, this variance can be compared between two different data sets, right? So the same example of males and females which we have used yesterday, the spending patterns of males and females, the same thing can be done from a perspective of variances. And when I am doing it from the perspective of variances, looking at whether there is a consistency in the variances between the two, which means the fluctuations of both the data sets is more or less the same, then I can say, okay, even their variances are more or less uniform. So the t-test which I am using for testing of the means, if it still confirms to equality, null hypothesis still getting confirmed, I can go ahead saying the null hypothesis can be accepted at this level of confidence, otherwise I have to reject the null hypothesis. That's what we have seen when we have done that independent sample t-test. Here it has given the variances. Initially, to start with, it has given the variances. You can do this variances as a part of the t-test also, or you can have a separate test for the variances, which is what we are calling as an analysis of variance or ANOVA test, right? So to get into that ANOVA test, I get into analyze, same compare means, and here I have ANOVA. ANOVA is nothing but analysis of variance. So here, whatever are the variables, I would like to analyze all the 5 all the 5 spending patterns, the logarithmic 5 spending patterns is what I take here as my variables. So let's say this 5 I would like to compare. For what? Let's say group wise, male and female, or gender wise, blah blah blah, any of the factors. So let's say I give gender wise, comparison. So here, if I do this, this is how I get my ANOVA report. What does this report talk of? It looks at 2 aspects. One, what is the kind of variance within each group? Within each group means males, females. What is the kind of standard deviation or variance existing between each of the groups? Between the males, what is the, not the average here, it looks at the standard deviation. So between the males, let's say there are 40 males, right? So for these 40 males, it takes the log long distance and looks at the standard deviation of that value. That is between the group.